Today, we're going to learn how to convert a binary tree heap into an array heap. Hello, I'm James Helfrich. A heap is a data structure where each element is greater than or equal to the two child nodes in the binary tree. Now, we can actually store a heap as a binary tree, or we can store it as an array. This video will demonstrate how to make that conversion. Recall that a heap is a binary tree where each element is greater than or equal to the two child nodes. Now, in this binary tree, we have the root node is 99, and this can be greater than or equal to 92 or 67. Now, we can convert this binary tree representation of a heap into an array representation of a heap. And we do so in the following way. First of all, we're going to call the root node level 1, and there's one element in it. And then the level 2, the next level below the root node, is going to have two elements, 92 and 67. And then the next level will have 4 nodes, and then so on and so on. Now, what we're going to do is we're going to assign an index to each node, and we're going to start strangely at index 1. And I know normally we start an array with index 0, but we'll see that the math is going to be much easier if we start at index 1. Now, the equation is as follows. For a given node, the index of the parent node is going to be the index divided by 2, and the index of the left child will be index times 2, and the index of the right child will be index times 2 plus 1. To illustrate this, take a look at node 67. Now, 67 is index 3. The parent node is index divided by 2. 3 divided by 2 is 1, and that's sure enough 99, which is our root node. And our left child would be 49, and 49 is index 3 times 2, which is index 6. And that is, and sure enough, the index of node 49. And then the right node would be index 31, which is index plus 1. Okay, let's convert this array representation of a heap into a binary tree. Now, the first thing we're going to do is we're going to stick 99 at the root node, and then 93, 19, and then 89, 85, 12, and 3 as we're going to go one level down, one level down, one level down. Now, I'm going to assign indices to each of the individual nodes to make things easier to understand, and I'll put the indices in our binary tree as well. Okay, is this a heap? And we can answer that question by taking a look at each and every node and making sure that it's greater than or equal to our sibling nodes. Now, at first, boy, 19, that does not look like it's going to be, it's going to violate the heap constraint. Because remember, we have to be greater than or equal to our child nodes. And 19, which is index 3, is a much smaller value than, let's say, 79 and 67 in index 8 and 9, which is much further down the heap. However, we only care about the relationship with our child nodes and not with nodes in other parts of the tree. Now, when we take a look at each node and look at its child nodes, we're going to realize this does in fact honor the heap constraint. So this is a heap. Now, let's take this binary tree representation of a heap and turn it into an array. Now, remember, I'm going to start at index 1, and I'm going to start at the root node and then go level down, level down, level down. And so it's going to be 99, 31, 93, and so on. And we're going to drop the indices in here to see, and notice my indices are a level order traverse, 1, then 2, then 3, then 4, then 5, and 6, and they're going to map the way we expect. Now, in this final example, we're going to take a given node in my heap, which is going to be index 5, and we're going to try to determine the index of the parent node and the two child nodes. Now, first of all, we're going to start with the parent node. Recall that the equation is to take the index divided by 2, and that gives me the index of my parent node. Now, 5 divided by 2 is going to be 2 using integer division. We ignore the remainder. And so therefore, I expect my parent node to be index 2. And my left child is going to be index times 2, and 5 times 2 is 10, and I expect that to be 10. And my right child to be index times 2 plus 1, which I expect to be 11. Now we're going to verify this by dropping all the indices into the tree, and we're going to see that we were correct. If you would like to learn more about how to convert a binary tree representation of a heap into an array, take a look at the C++ data structures textbook.